Good afternoon, beautiful people. How are you today? I'm doing well too, thank you for asking. So if any of you have had a chance to talk to me or been around a conversation where I've been geeking out here this week, then you've heard me talk about Postgres. So this talk is probably no surprise to any of you who have come to see me at any conference. Postgres is an old and dear friend to me. I absolutely love this database. For those of you who came to my talk yesterday on Rethink DB, you're probably going to be saying, what's up with you? 2 database talks. Hey man, it's me. Also, I want to apologize again for being rude American. I only speak English. And I want to thank the organizers, Michal and Rafael, again for translating the slide for me so that I could translate it into Polish. And yeah, I think that's correct. So. At least they told me it was. Anyway, my Google Polish is still a bit rusty. I wanted to start off talking about a little bit of a story. Every time I come to Europe, and I'm so lucky to do so, to come to a conference, I come to Europe, and I just spent the last year traveling in Europe with my family. I love to go out at night. And one of the things that I really love is the way that European buildings, like the old, beautiful churches, right, are lit up. And I walk around and I just take picture after picture and I get lost. I love it. And you walk through the streets and it starts raining and then it just becomes magical to me. And the reason why I like it so much is because as an American, our sense of history goes back about 100 years. On the West Coast, it's about 50 years. The oldest buildings you find are just pathetically not old. On the East Coast, it goes back maybe 200, 300 years. But to come over here and have that sense of history is comforting. There's something about it to see these old buildings that you think, wow, they've been here forever and they're going to be here forevermore, and you can kind of sit there and go, whoa. It's really special to me. And I just wanted to show you this really quickly too. This building right here is a place we stayed at in Bernfeld, Germany. It is a 720-year-old farmhouse, and you can find it on Airbnb. We stayed there. We stayed there, and I remember asking the host, and my German's horrible. I actually tried to do it with Chad the other day, 700 something or other, and I asked her 3 times over, really? And she said, yeah, 720-year-old sheep farm. And I took a picture of this doorway right here because, I don't know, there's something about this doorway that just got me. And you think about the generations of people that have walked through this doorway. I can't even comprehend it. I mean, you think the Renaissance went off, this doorway was here, Dark Ages, Reformation, Henry VIII, Queen Mary, not quite as old as Casimir III, did I say that name right? Not quite as old, but close, very close, 700 years old. This is the inside of the house though, and this is the thing that I liked too. Those are the hand-hewn logs inside. That was the original logs, we're supposedly told, of the house, the foundation there, but everything inside of it, look, it's a flat screen TV. It's all kind of new, it's kind of groovy, and there's my daughter running around. She loved playing inside of there. Brand new kitchen with a granite countertop, and like all new things. Why am I bringing all this up? Because to me, this is Postgres. This is history. Postgres has been around forever. It is rock solid, it is your good friend, it is history, but it's also got some cool new things, man. It's got like the brand new countertops and whatever. So the one thing I'm gonna do is I'm gonna troll myself. So if you came to my talk yesterday about Rethink DB and I told you how cool it was and yay, everything's rad with Rethink DB, I'm trolling myself today. I'm going to tell you why Postgres is probably in a lot of ways just as good and in some ways actually better. Because that's what I do, troll myself. Because I actually, and this is really weird, I can hold 2 ideas in my head at once. It's really strange. I can actually love 2 technology things at the same time. There's a joke there and I'm not even going to say it. So there's good things about doing document database stuff with Postgres, and there's bad things. You're going to see that today. With Rethink DB, I focused on some really good, loving things, and I mentioned that there was a kind of a scale between the 2 sides. When you're working with a document database, there's kind of the ops side with Cassandra and React, the high capacity, scaling out stuff, and then there's kind of the cuddly side with Mongo and Couch. Well, if I was to put working with Postgres in there, it would be just a little bit to the ops side. Because Postgres is a great database, but when it comes to the document stuff, it's not quite as cuddly, but we're going to fix that, and I'll tell you more about that in a minute. So consider this document. If you came to my talk yesterday, you saw this document. This is a Shopify sale, and it's a little bit small, but let's zoom in on it. This is a big document. I removed a lot of the data here, but it's huge, right? What I did is I took this document and I generated a bunch of fake data and I put 1,000,000 records into Postgres and I started playing around with the document stuff just because I wanted to see what was there. I will just summarize this for you. Of course, Postgres handled it amazingly. I then thought, well, that's not really, I mean, you're not really going to sit there and jam over 1,000,000 records. So I reduced it a little bit just to see, because I wanted to record it so you could see it. This is 10,000 records, 10,000 of those big sale documents. And I actually decided to see, okay, what can I do to actually query that document and do a sales rollup? And did you see how fast that was? Bam. That's just Postgres, right? It is fast. This is indexed. And it works just as you would expect. Now, of course, that SQL that you're seeing, that's a whole other story. We can talk about that in a second. This is what's called a co-occurrence report. It's a little bit more complex analytics. The problem here is I have a product, the top-selling product. What are the other products that sell along with it? So you want to know those two things because you might want to do offers for when someone picks your top product. Hey, other people like this too. Well, it came back really fast. That is a really complex query where you do some joins in the table, blah, blah, blah. The neat thing about doing documents, and I heard someone talk about this before, the one benefit that a document database has over a relational structure, no joins. And it's really, really fast. Now, the trick with this is, can you actually get down and transform the data without destroying your system? Is it an expensive operation? I'll just cut right to it. With Postgres, no, it is not. And I'm going to show you that in just a second. So, if I could wrap up everything I wanted to tell you about Postgres and documents, it's possible, and it's Postgres, and you can do it. That's like probably the best thing I could tell you about why you would want to do this. Document database stuff with Postgres is possible. Whoop-de-doo. More than that, it is actually fun to actually sit there and watch your relational system turn into a document system, and then you kind of see, well, what else can I do? And then all of a sudden you have this overwhelming thing like, oh my God, I can do everything that I can do in system X with Postgres, and then you see how fast it is. And that's when it gets exciting, because you have fun, and you see the possibility, and then you're like, oh my God, this could actually be something amazing. So, before I get ahead of myself, would I really do this? Relational systems are not meant to be document systems. I mean, Postgres is founded on the idea of being a relational database. Why would you ever put in document database stuff with a relational system? So let's talk about this real fast. I mean, I'm going to keep saying this. Probably the primary reason you do this is because it's Postgres, and Postgres is amazing. That's really not a reason, but it actually kind of is. Postgres is actually the best of both worlds. You have a whip-crack relational engine, right? It is one of the best out there. And you also now have this ability to store JSON as binary in Postgres. I'm going to talk more about that in a second. You can do both things. And I can't really say that with enough emphasis. You can do both things. You can start with a document, slowly, gradually move it into a relational structure as you want to without changing your back end. The neat thing about this is Postgres has had this kind of unstructured data for a very long time. Hstore is a key value inside of Postgres. That's been around. JSON has actually been around in text style. Arrays have been around. Ranges, TS vector, latitude, longitude, geodata. Postgres has a very rich data type system, and you can store just about anything in there. The thing we care about today, though, is the GIN index, generalized inverted index. It is a specialized index for working with documents and loose text. Why is that important? Because when you start working with things like JSONB, that's binary, you can actually index that JSONB inside your database, and it goes really fast. I'm going to show you this in just a second. So, a starter set of reasons why you want to consider this: fast, ACID compliant. That's huge. A lot of IT departments won't even let a database into the company if it's not ACID compliant, which I totally understand. ACID is atomicity, consistency, isolation, and durability. That's kind of the foundation of why you use a relational database, to guarantee that the writes that come in actually stay in the database and don't explode. It's a proven technology, but I'm not really answering the question as to why you would actually do this, because there's other document systems out there. If you want to use a relational database, you can. And in short, you want to get your rocket to Mars first. That is one big reason. The people who land on Mars the first time are the ones who are going to rule Mars. That's pretty much it. If you've ever read sci-fi, you know that. So the idea is when you're building your application, you're trying to get it to market, you need to get it out the door. If you're sitting there with Entity Framework and you're slamming your face against the table trying to figure out why your migrations aren't working, well, the answer is because you're using Entity Framework, and you have a lot of problems you're going to have to deal with. Meanwhile, your opponents out there, the people who are competing against you, are using Node and Mongo. Let them make that mistake. Let them. But it doesn't mean you have to. You can use a document, open structure, and open schema to get your application out. Figure it out later on while you're sitting on that rocket, right? While the rocket's taken off, then you can normalize and do all the things you want. So that's one big thing. The second is there's all kinds of data out there, all kinds. So you might have web API calls coming in from, let's say, PayPal, PDT, or the IPN. You might have webhooks coming in from your service. And you'd probably be sitting there one day, and I know many of you have done this, I have, where you're looking at the data that comes in from those webhooks, and you're thinking to yourself, man, that is so much data. If I have to actually model that with Entity Framework, I am going to have a cow. And many times I have tried to do this, and I've said, just skip it, right? I'll just take this bit of data. I really only need to know the payment was successful, and I'll take that transaction ID, and I don't care about the rest. Me, 5 years after the fact, if I could punch myself in the face 5 years ago, I would. The reason why I'm saying that is I went through the process of selling a business. I had a business I built from the ground up. I used Rails. I had a good time. I got out there. I got to market, and it was successful, and everything was happy. I sold that business. And when I was selling that business, I was asked about 1 million different questions that I could not answer because I didn't have the data. And I know if you think about the projects you've been working on, have you really captured all the data you need 5 years from now, 10 years from now? I don't know. Well, see, you come to these decisions about trapping the data, and if you have to model it, you think, oh man, my database is gonna, it's gonna get too big. It's gonna end up like this mess right here. And then you just say skip it, and you don't trap it. So that's one major benefit of having a document system. Consider the sales document that I told you about before. How many tables do you think it would take to model that in a relational system? I counted 12. So again, you probably look at this and think, we don't need all of it, do we? And the answer is usually no. And so you skip corners and you say, forget it. Now you can do a hybrid approach. Let's say you wanted to either start out putting everything in a document inside Postgres and then move forward. Well, you can. This would be step 2. This is that exact same sales document, but now what I've done is I've broken things out. So inside of here, at the very bottom, you can see I have payment details. That would be a response coming from Stripe or a response coming from PayPal. It doesn't matter. I don't know, because it's loose, schemaless data. I can throw it in there. It could be either one. I don't have to have this monster schema just for PayPal, monster schema for Stripe, or whatever processor you use, right? I can just jam it right inside here, and right above that, what processor am I using? I could just tell myself in the database. I can write some code later on and figure it out. So that's it. That's like pretty much the best I can give you right now. Get your app to market, get it out there to show people, and it's fast, and it's ACID compliant, and if you need more reasons than that, you're crazy. Just a small opinion, So let's talk about JSON versus JSONB. We're going to transition now kind of into talking to the nuts and bolts. Let's say you agree with me. Let's say you're saying like, okay, I'll just agree with you. Shut up and go away. I'm used to that line of discussion. So the differences between JSON and JSONB are actually quite important because Postgres has both data types. It has actual JSON and JSONB. So what is JSONB? Well, it is in the name JSON binary. So binary JSON is how MongoDB stores its data. Now you have that exact same thing here inside MongoDB. Does this thing just go weird in volume? Anyway. So why do we care about that? Well, let's take a look. This is regular old JSON in Postgres, preserves white space. It's just text. So when you put JSON into Postgres, just plain old JSON, not JSONB, it gets stored as text. It goes through a validator first to make sure it's valid JSON, and then boom, right into the database it goes. White space is preserved, and it basically is just a big fat text blob. With JSONB, however, all that white space is removed because the string actually doesn't matter. It's actually tokenized and turned into a little B tree, and that's what it looks like. So text representation right out the window. It's binary. Second is there's no repeated keys. This is actually valid JSON here. You'll notice I have 2 keys that are both ID. You can stick this into a JSON record, and it'll be fine. Who cares? It goes to the validator, and that's just fine. However, with JSONB, that second key gets removed. Or excuse me, the first key gets removed. The second key will actually remain. So you get no repeated keys. It'll take that out. So that's just something you should know. Third thing is the key order for JSONB is not preserved. So it's because the JSON document you put in there is broken apart into binary and then reassembled when it comes back out. How it puts those keys together is just random, I guess. I've seen this in a couple queries. It just kind of goes all over the place. So you cannot depend on the key order being preserved. Neither should you. No partial updates. If you think about this, it sort of makes sense because the JSONB column is just a column inside of a row inside of your table. So if you're going to run a query, you're going to have to fully swap out that row. If you saw my talk yesterday with Rethink DB, you saw that I was able to do a partial update and go and change the name. Yeah, you can't do that with Postgres. So how do we actually now work with this stuff? Let's dive into the details and see what it looks like to actually play with this. Consider this table right here. This is a products document table. I'm going to store all my product information right inside of here. I'd probably create it and have a primary key, because you have to remember this is still a relational system. But even then, other database systems like Mongo or Rethink DB demand that each document has an individual ID. Raven does as well. So you're going to have to do something with a primary key. So I'm going to set that. Put the details in as JSONB, and then I might have some timestamps up in there for some meta information. So let's say we want to pull some data out. We want to pull out our POI document that I was playing with yesterday in the Rethink DB thing. This is the query. It looks a little bit weird, doesn't it? But it's SQL. It's SQL with a new operator. The thing looks like a toothpick, the arrow. That is saying, take this key from this blob of JSONB and show it to me. In this case, I want to see the name, I want to see the price and the description, because I know they're in there. If they're not in there, it's going to come back as null. The very bottom bit here, that's the interesting thing. That is called a contains operator. So what it's doing is it's taking the JSONB, the string that you see, that little bit of JSON right there at the bottom, and it's matching the details. It's saying if this is inside of this, or if the details contains this string blob right here, then show it to me. You can rewrite that using this. You can basically just do a comparison using an equal sign, but this is generally not a good idea. The reason why is this will do what's called a sequential table scan. It has to go off every single row, materialize the document, and then run that equality. So if you only have 100 records, it's not that big of a deal, but if you have like 1 million, you're not actually going to use the index. And that's what the important thing is. This guy right here is a specialized operator in Postgres. It's the contains operator. It's specialized for JSONB, optimized for the GIN index, the one I just told you about. So you always want to use that. So let's go with the first scenario. We're going to go all in. We're going to have all of our data stored as a document in the database. We need to come up with a strategy. Right? How are we actually going to structure this table? What would actually work? Do we just have a single table with an ID and a JSONB field, or what are we going to do? So let's see some strategies here. The first one is kind of what I just showed you. Let's go with just a single document table. We're going to have a primary key. We're going to have a body that's JSONB, and then we're going to have some timestamps. So that's where we can start, but we can do more. We can also add a TS vector field, and that's going to sound a little bit wonky, but for those of you who use Postgres, you'll know what that is. This is the way Postgres actually does full text indexing. So has anybody here used full text indexing with SQL Server at all? Yeah? So basically with that, you have to, well, correct me if I'm wrong, but the way you used to be able to have to do it is you had to kick up a little catalog, a little index on its own that kind of sat in this little black box, and you kind of told it which fields you wanted to index on which table, and it would sit there and churn and burn and churn and burn and churn and burn, and then you could run it. But you had to run it against this binary stuff that was just off somewhere in the operating system. Postgres doesn't work that way. Postgres, the full text index is actually a data type, which is weird. So what Postgres will do is it'll go in and ask you which fields you're trying to index, and it'll chunk that data out into little tokens with word score and a bunch of other stuff stemming, and it'll actually just store it as text in a field that it'll use later on, which is pretty interesting stuff. I'm not going to dive too deep into that, but what you can do is you can save that full text index right in your table if you want, and you can query it later on. So that's a great structure to start with. The second thing I'll need to do is I'll need to run an index. And this is a SQL for running an index on that table. So here in the first one, I am creating a gen index, the generalized inverted index, on the body field, and I'm sending in a little switch right there. It's a little command that says, go JSONB path ops, go into my document and index every single key and value that's in that document. You don't need to do that. You can specify an index on each individual key if you like, but if you want to just index the whole thing, that's how you do it. The second index I'm going to create there is for the search field. You can use the same gen index on the TS vector search field. Why would you do that? Because it makes full text indexing rocket fast. It's pretty neat, but the API really sucks. That's the problem. So if you're trying to remember SQL and JSON, and oh man, that Rethink DB stuff yesterday was pretty nice. Just tagging functions together and building out things, it just makes more sense. Why do I have to do all this? Take a look at this. I mean, the select thing with the little toothpick arrows and trying to remember how all that works with the @ sigil down there and the writing JSON in a string. That's just a mess. I didn't even show you the insert statement, right? The insert statement is brutal. Could you imagine typing all that out? And this is the part where I started out by saying there's good things and there's bad things, but we can rescue this because it's just Postgres, right? It's just Postgres. And the deal with what I mean by that is you can program Postgres. You can't program MongoDB, you can't program Rethink DB, nor can you program Cassandra. You can't store routines in these other systems, but you can store routines in Postgres. They're just functions, which is pretty neat. We're developers, we're geeks. If we don't have an API that we like, we'll make our own. Speaking of, that's exactly what I did, because I did not like at all the document API stuff for Postgres. It's way too lower level. What I really wanted to do is I wanted to have something that approximated what MongoDB does. MongoDB gives you a save routine that will create a collection if it's not there, right? It'll jam the document in there, create an ID for you. That's what this routine, well, actually this routine just creates the table itself. Everything I just showed you is it'll create the table on the fly. This is used by the save document function that I also created. This thing is fun because this thing will actually create the table, put the data in there, it'll get indexed, right? And then down below, it'll actually call out to this other function that I created called update search. This uses some convention. I built this key list. You can see that array right there. And by the way, this is JavaScript. Did you notice that? This is JavaScript function running inside Postgres. Did you know you could write JavaScript functions in Postgres? You can. So this is the PLV8 extension. If you don't like JavaScript, you can plug in Ruby. Or you can plug in C#. Just kidding. You can plug in Python. Could you imagine writing C#? That'd be really funny. I mean, maybe you can. Actually, I should not say that. I bet with Postgres, you just find these things. It's pretty crazy. Anyway, back on track. So what I did with that array is I came up with just a conventional set of fields of things that I would typically like to have indexed for full text searching. So if there's a name field inside your document, an email, address, first, last, you get the idea. What this function does is it goes in and it just updates the search field in that document table structure I told you about before. It does it automatically. Okay, I could go off on this. I'm just going to tell you right now that basically what I ended up doing was creating a little project. It has 7 functions in it. And I wanted it to do everything that MongoDB does, but better. What do I mean by better? That save routine that I showed you will actually accept a document array. So it doesn't have to just take an individual bit of JSON. You can stick in an array. Let's say 1,000 documents, it'll spin out 1,000 records and stick it in the database in a transaction. So someone here yesterday, or someone in the talk yesterday asked me about Rethink DB and said, can you do transactions in Rethink DB? And I said, no. Can you do transactions in Postgres? Yes. So that's big, that's ACID, yes. So anyway, this project right here is up on GitHub. If you guys want to kick up your laptops and go take a look at it, you can. Tool through the code, I've actually split out all the SQL files into individual files there in the SQL directory. If you want to just grab the whole thing and not worry about it, api.sql is just a big fat dump, just pop it right in. Then you have document database ready to go. So that gets data into your system and you have a way to store it now. What about pulling data out? That's where the fun starts, because systems, you saw me yesterday building these complex queries out with Rethink DB. That's where you kind of get the feel of a database, because getting data in there is, well, it's not that hard, right? Updating things, moving stuff around, not that hard, but actually putting together stuff to get out of the database, that's where things get tricky. So let's take a look at some queries. I've already showed you this kind of in the beginning, but what is this? Well, your eyes should be adjusting a little bit right now because you've already seen what it looks like to pull out JSON from the database. So the very top chunk there, and I'll talk about what that chunk of SQL is in a second, but that's a simple select statement to pull some data out of our sales document. The second part of the query here transforms it into what's called a fact-ready display or fact-ready table. And then down below here, you can see that there's some roll-up information on dates and other things. I wanted to show you this again because that same query that you just saw, this is the Rethink DB query. This is what this looks like. I wanted to kind of go back and forth between these two just because it's all going to be syntax gymnastics to pull the queries out. There's a difference though here. The difference is that this is a function language that you're going to have to learn, and ultimately this is SQL that's been around for years. So some of you might be saying, yeah, it's SQL, but that's kind of declarative and procedural garbage, which you'd be right. But it doesn't mean you need to use declarative procedural garbage to do your queries. We're going to see in just a few minutes why that's not always the case. But what is it we're trying to do? I just want to frame the discussion here and give it some context. When you're pulling data out of a document in a document database, you're doing a number of things. The first thing you're doing is you're deciding what data to pull. What documents do you want? So I call that shaping, if you will. You can also call it mapping, if you're kind of into these big document systems. Mapping. You're going to pull that data out, you're going to transform it, you're going to do the things you need to do, and then you're going to roll up on it somehow. You're going to roll up to do some analytics. In the document database world, you would say you're going to reduce it, right? Pull out, map it, reduce it, and then there you go. Same deal here with Postgres. You're going to pull the data out, transform it from a document structure into a tabular structure, and then you're going to have some SQL fun. So let's revisit this document one more time. That is our sales document. I'm showing it to you one more time just to show you this is not a trivial example of like, hey, I've got just a few keys. Nuh-uh. We actually have a really big document, thousands of records in the database. We want to pull some data out and take a look at it. The way we do this in Postgres is with a thing called a common table expression. And this is just ANSI SQL. This isn't funky Postgres stuff. You can do this in SQL Server. You can do this, I think, in MySQL. It's an ANSI standard. Which of these database systems, if you had to guess, implements the ANSI standard for CTEs the best, the most complete? If you're thinking Postgres, you'd be correct. SQL Server does not implement CTEs to the degree that Postgres does. Don't ask me why. I don't know why. So what are we doing here? We're doing two things. I want to explain this SQL to you real fast. The with block is basically saying, here comes some SQL, and I'm going to give it a name. Here comes a query, right? With items as, and inside of here is just going to be some data. Here comes a select statement, let's say. The first function that you see up there, JSONB array elements, that is a Postgres function specific to JSONB. Of course, JSONB is in the name. What I'm telling it to do is I'm telling it to take the embedded items array and lift it out into its own individual rows. You saw me do this yesterday with Rethink DB if you're in my talk, where I used concat-map, and I took all the array elements inside of an embedded document. I'm sorry, it took an embedded array inside of a document and lifted it out into its own top level, if you will. That's what this function is doing. It's taking all those items and making them their own records returned in the query. So the invoice ID and the date are going to be repeated along next to all the items. Then I have a second part to the CTE here, and I'm unwrapping that data even more. So the first thing that you're seeing there is just standard Postgres stuff, date part. That's how you pull out date information, and I'm flattening this because we're going to analytical mode right now. We're not in transactional mode, so when you go into analytical mode, you kind of want to denormalize everything because you want to roll up on it later, and speed is key. So here we're pulling out the quarter, we're pulling out the year, the month, and the day. And then down below we have some more funky SQL that is Postgres specific. We have this function called JSONB to record. So I'm going to back up one bit here. At the very top, we pulled out the array items and made them their own records, right? But each one of those own records is a chunk of JSONB, right? So what we need to do now is take those rows, those chunks of JSONB, and turn them into tabular records. That's what that function does at the bottom, JSONB to record. When we do that, we have to cast it as something, and that's what this second part is. I'm going to pull out SKU, vendor, price, and quantity of each one of those chunks of JSONB, so I can now see it in a column. If you don't understand all this stuff, it's okay, because what I really want you to understand is the structure. The structure is a big thing here, and if you leave here with thinking or knowing nothing else, just look at this. This is what a CTE looks like in Postgres. One operation, second operation, third operation, fourth operation. The results of each one is being pushed to the next. Have you guys seen this before in this conference at all? Functional programming. That's what this is right here. You're taking the first query, shoving it into the second, the results go into the third, the results go into the next one, and I'm going to give a little shout out to my F# friends. I told them I was going to put some F# in my slide deck. Yes, F#. Come on, where are you guys? Thank you. I have to put a little troll face in there. But that is some F# notation for what it is we're doing. We're actually creating a functional pipeline. And this is how we can approximate that Rethink DB syntax I did yesterday. This is the same thing in Postgres. Okay. So I just wanted to show this one more time. What we're doing here is we're rolling up the data, and we're able to now take off because, all in all, this is just SQL. And that's kind of the biggest advantage I want to leave you with right now. The storing of the data, as you saw, was fairly easy. Once I had those functions going, I built my own API, right? I could store the data in there. I could query it with full text indexing. I could do all kinds of stuff. But after the fact, when I want to query and pull the data out and do something with it, I had to know a little notation to get the stuff out of there, and I had to know a few core functions. But once I was able to transform the data into a tabular structure, that's when you take off, because it's just SQL. After that, groupings, all the analysis stuff that you know how to do, compare that with this. That's not just SQL, right? Which is okay, it's a good language, and I'm not trying to say it's bad or anything. I'm just saying to do the exact same query, that's what it looks like. So if you're thinking that Postgres syntax looks a little weird, well, keep staring at that. Okay, so just to recap the entire talk, why use Postgres as a document database? Here's your reasons. It's fast, fast, fast. It's built to scale. It powers huge systems. Instagram, I mean, I could stand here and go off forever and tell you all the big systems, big enterprises. Postgres is a workhorse database. It is used everywhere. It's reliable. It's database history, if you will. ACID compliance is massive. If you think of the number one problem in NoSQL systems today, especially document databases that are horizontally structured, the number one problem is that they lose data. Postgres doesn't lose data. Postgres just doesn't lose data. It's amazing that way. Unless, of course, you make it lose data, then it will. You can gradually normalize your way to a relational if you want. Start your project out fast. Get some speed under your belt. Get some motion going. Serialize your data in. Pull it back out. You can do this in .NET. You can do it in any platform, really. Just use it as a document, but then slowly normalize out. Change the structure of the tables you go. If you want to have implement normalization rules, you can. If you don't like the way Postgres does something, change it. Make your own functions. It's easy to do. You saw me do it in JavaScript, but you can just do it in plain SQL. You can choose PLPG SQL, which is a little funky to use. Doesn't take much time to get up and going, but you can do it. And then you saw with the queries that you can have some functional fun. You can implement SQL in a functional way, which a lot of people don't believe me, but hopefully you just saw it. And then finally, when you're doing your rollups, it's just SQL. So, oddly, every time I've practiced this talk, I've come in at 47 minutes exactly, and somehow I'm at 34, which I think is cool because it's the next to last talk of the day. So I'm just going to end it right here and say thank you. Oh, and by the way, if you have any questions, please shout them out.
What is the performance difference between this database and yesterday database in about 2 million today?
The question was 2 million records. Yeah, sure. No, it's a great question. Rethink DB versus Postgres with 2 million records. I didn't quite talk about this so much, so it's going to be a little bit of a long answer, but I think it's a very important question. When you're talking about speed between the two systems, you're talking about apples and oranges. So let's start out with saying this. If I had a MongoDB server or a Rethink DB server right here, same size, and a Postgres server, same size, Postgres would utterly destroy those systems, utterly destroy them. It is so optimized and so fast for a single box. There's no comparison. It's like an order of magnitude difference. But you start scaling this thing, you're going to be buying a bigger box for Postgres, right? Because it scales up. So the Mongo fans out there are document DB fans that say, oh, I'll just tack on another instance, and next thing you know, you have parity. So to answer your question is kind of hard. hopefully I have. Like, if you have 2 million records, the amount of records don't matter. What matters at that point is the index. So with Rethink DB, you can optimize with secondary indexes, and you can actually make those queries scream real fast. So I actually queried 1 million rows. I hadn't done 2 million, but 1 million. So maybe just consider I do it twice. But I did a pretty deep query over 1 million records, and it came back in 9 milliseconds. It came back, and it was really fast. So when you're talking about speed in these systems, it's kind of hard because you're not considering load. And when you start adding load, that's when those document databases shine, because they're able to handle the load because of sharding and everything else. That's where Postgres kind of buckles, but as I keep saying, it's Postgres. So the more you build it up, the more it's able to handle that load better. Did I answer your question? Okay. Anybody else?
In terms of speed, to search from the JSONB thing versus a retrieve.
So the question is, how is the speed when you search on JSONB versus just a regular field? Regular field's always going to be faster. The reason why is the JSONB has to be materialized. To some level, you're going to have to do a B-tree search inside of and a matching operation inside, and that's actually quite fast. But it's not going to be as fast as a table match. Now, to flip that around, or excuse me, as a record match. To flip that around, if you find yourself querying on fields in a document table like you saw me have here, you're like, oh, we're querying on, like, let's say an invoice key or an email. Take it out and stick it in a row, and you can have it be mirrored. There's ways you can do that, and then you can index it, and then you have all the facility right there to query it that way. The other thing you can do that a lot of people like to do is that you saw me do the full text searching. Use that, because that is insanely fast. And the only way I can to say this is just to try it. It's utterly mind-blowing how fast that is. Does that answer your question? Because you do have options. I guess that's the kind of the answer I want to give you. Anybody else? Yeah.
Can you just get count of items instead of get an entire list and group and etc.?
So like the account of items in a sale, do you mean?
Well, yeah, you can say that.
Yeah. So the question is, can you just do counts? Can you do aggregates or like counts?
I'm not asking you if you can do aggregate, but
Yep.
if you have just a function that I don't just get
Yeah. Oh.
the
Yes.
items count.
Yes.
Without group.
Yes. It's I think it's if you have an array and you want to know, the question is, can you do just a count of items in an array? Like, is there a function to do that within a JSONB? And yes is the answer. And I can't remember what it is off the top of my head, but I think it's array elements or something like that. And it gives you back the count of the items in an array inside of the document. There's a number of JSONB specific functions, and if I was to dive into that, you'd probably all fall asleep. But it's actually a fun read. And I'll be honest with you too. It's a fun database to play with, and it's a fun system. But trying to get it to work in a relational system, like it is still SQL, and it's still a relational back end that's trying to do document stuff, and especially writing those strings can be really like punching yourself in the face. It can be frustrating for sure. I'm not going to tell you it's bullets. It's not like Rethink. It's not as good as that in terms of niceness. Any other questions? Yes. So the question is there any providers in .NET for handling JSONB? NPG-SQL is the .NET driver, and I just played around with it, and I was pretty impressed at how complete it is. In fact, I found it to be more complete and better implemented than the Node driver, which is weird because the Node people rely on JSONB and Postgres way more than I think people do in the Microsoft world. But the NPG-SQL driver is really well done, and it has, if you're passing a parameter in, it has a special JSONB parameter type. To further answer that question, JSONB in Postgres is treated as a string. So anytime you're doing a query, you saw me write it, it's just treated as a string, and you have to make sure you have a valid JSON, and then off you go. Okay, anyone else? Anyone? Shout it out. Okay, thank you so much.